Okay, tonight we have Jeremy Kuzub from the RASC, which Royal Astronomical Society of Canada, and he's going to be presenting A Year of Chasing Aurora. Jeremy has a Bachelor of Science in Electrical and Control Systems Engineering from University of Alberta, Master of Science in Systems and Computer Engineering from Carleton University. He's an accomplished computer science professional since 2010, and he's the owner of the website called Capture North. That's capturenorth.com. It's a photography, imaging, and education project that aims to share the wonder of the northern skies. The goal is to combine the science, mystery, majesty, and wonder of the Aurora. Again, that's capturenorth.com. Check that out. It's really a beautiful site. And with that, Jeremy, you can take it away.
Thanks, Mark. And thank you very much to both the club and for allowing me to speak today, and especially Mark for coordinating this. As Bob was mentioning before, it's been really wonderful to see that these sort of Zoom presentations have brought together so many astronomy clubs from all over North America, especially with the Royal Astronomical Society speakers, which you've invited in past presentations. And we really appreciate that it sort of jumps across all the borders, whether they're provincial, state, or our country, and that we all have something to share. And like having Reg being able to join in from Anaheim, for example, that's wonderful. So I'm really glad that we can have these hybrid presentations and share with each other, since we all live under the same night sky, but we all get a different perspective on it. And that's what I'm going to try and share today. I'm an enthusiast and an engineer by training, so I like understanding things as well as enjoying them at the same time. I'm just going to share my screen here and begin the presentation. And just to verify, if anybody wants to nod that they see a full screen presentation right now. Okay, I see the big thumbs up. Excellent. Originally, I gave this presentation in 2020 to the Royal Astronomical Society of Ottawa in Canada. That's the capital of Canada. And now it's become a year or two of Aurora chasing. I've updated it for this presentation because some things have happened in the last year that I'll add as an addendum to this. Like any craft or hobby or pursuit, it evolves over time, and you learn, you get humbled, you learn some more, you drop a camera, you save up some more money, you freeze your toes, and you meet some wonderful people along the way. So that's been my journey, and I'll share it with you both from a technical perspective and a sort of a travel log perspective. Like anything with the night sky, there's a ton to learn, and no two people see it the same way, I think. So this is me on the left in Yellowknife, which is pretty far away right now, but that's sort of the Aurora hunting or Aurora viewing capital of Canada, and maybe one of the best ones in the world. Even on a quiet night, the Aurora will find you there. You don't need to look at the forecast aside from checking for cloud. Among all the different things that can happen, if you get some really good photos, you can do things like on the right is sharing them at a Christmas fundraiser craft show. And one thing I took away from having all these images that I captured from my various trips was that when I was offering these cards and prints for people to look at and to see at this particular craft show, everybody had a story about those locations. It wasn't some faraway mystical place. They'd say, oh, I was there. One of the photos, somebody said they actually proposed to their spouse in that same location. I think it was Marsh Lake in the Yukon in Canada. But everybody had a story, whether it was aspirational. I've always had it on my bucket list to go up north to Iceland, or it was a story they had from working up there with mineral exploration or something similar. The Aurora is something that everybody can share because it really does fill the whole sky, whether you're working up there or whether you're actually chasing and doing the photography. Here's where I'm living right now on the far right of the screen. I'm in Howe Bay, Nova Scotia. It's kind of a dark sky area. It's a 21-hour drive to the Seven Ponds Nature Center through upstate New York, just in case you're wondering the context here. So again, it's wonderful to be able to speak to you tonight. And And I hope we can do more collaborations like this between RASC and between other clubs. One thing you notice about Aurora chasing is that you don't need a huge amount of equipment. Even, I think most people can be Aurora chasers. If they were overhead and you had your iPhone 12, 13, 14 out, you're going to capture an image of the Aurora. And in Canada, it's actually kind of a big part of our identity, I think. You'll see some of the stamps with photographs from Ellen Dyer, which is one of our most renowned astronomical photographers. The Alberta Aurora Chasers Facebook group is one of the largest Aurora Facebook groups. I think they're up to 170,000 members, and they actually collaborate with the scientific community quite extensively because of the volume of imagery that they capture. That's actually a good database for learning new things. And as you'll see in this presentation, there is still a lot to learn about Aurora and a lot that we don't understand. Finally, you'll notice the Royal Canadian Mint has a lot of glow-in-the-dark kind of Aurora coins. And so it's really, it's a part of our identity, I think. And it's quite amazing when you see it, quite magical. So people are brought together by that. The fact that the whole sky can fill up at once and you'll just be in awe with the people next to you. You won't forget that experience. And I think that's sort of the dopamine-oriented reward of Aurora chasing. So tonight we're going to talk about sort of 8 little sections. We're going to talk about the history of Aurora chasing all the way back to when it was film and much more tricky capturing. We'll talk about where Aurora come from. If you're going to chase something, you have to understand how it behaves, and that starts with the sun. And I'll give an overview of sort of what you might want to understand about the sun in order to successfully chase Aurora on your travels. We'll talk about the behavior of the energy from the sun, which is the auroral substorm. It's not simple how the sun and the earth and the magnetic fields and particles between them interact. A lot of models simplify that, but the fact is nobody understands all aspects of it. It's very much an open area of investigation and understanding, but there's enough to understand there to know when to go out at night and to know when to just stay in with hot coffee. We'll also talk about the construction of the aurora. We see the colors, we know some of the colors, kind of predominantly green, or in Chris's photo, there's also the reds and the blues. We'll talk about the causes of those and how they interact with each other. So basically, we're going to build an aurora using a color palette of emissions from the energy that comes from the sun. Next, we'll look at forecasting. So basically, what is solar weather? What can we predict about when there's going to be good aurora to be worth chasing? For example, when's a good time to go out in the backyard, or what's a good time to get on a plane and fly to Iceland? These can be expensive decisions sometimes, and you want to know as much as you can before you go. We'll talk about the equipment a little bit. It's very accessible equipment, but we'll still touch on some of the interesting things that come up with aurora hunting. And then I'll share a little bit of my trip diary, which, as I said before, is kind of extended past 2020 into spring of 2022. And finally, because we all end up sitting in front of our computers, whether we like it or not, there's the big element of offloading your photos and processing them, and what do you do with them? In aurora photography, there's often the case where you go months without seeing what you want to see, and then suddenly you'll fill up a memory card with 4,000 exposures in one night. Then what do you do with that? Which one's the best one? Do you turn it into a time lapse? Do you put it on your wall? Do you share it? So we'll talk a little bit about sort of what you do when you hit the gold mine, so to speak, of interesting photography. So let's start with the history. I call this Aurora chasing then and now. You'll see a QR code at the bottom of anything that has a link. So if you have your phone, just take a picture of your screen or screenshot your screen, and that QR code will link to the appropriate URL. Stephen Hughes wrote Catchers of the Light. It was sort of the forgotten lives of men and women who first photographed the heavens, not just the aurora. But it's very biographical, and it talks about the first people to pioneer the techniques that we use now, and it was a very good read. I'd recommend it. Here are two of the first photographers of the aurora. There were photos before Martin Brendel in 1892, but he was the first person to get a published photo of the aurora from Norway. And that's the actual photo right there. It's a single aurora curtain stretching overhead, which you'd often see in Norway. And he used a 210 millimeter lens on a 9 by 12 centimeter silver plate. It was a dry plate. He specially sensitized it to get the ISO up, because it's always been a battle. What's the highest ISO, the highest sensitivity you can get? It started in 1892 and it continues to this day. And he shot with a f3.5 lens. And these days there's much brighter lenses that collect much more light at a better focus. It took another 50 years or so for the first published color photos of the aurora. I believe those were in Life magazine, captured as a series by J.R. Ironman, and he photographed them in northern Canada. And he was using, again, a bellows camera. I think it was a 4x5 film, and he pre-sensitized his film. If you slightly expose film before you actually shoot with it, it effectively boosts the ISO. I think it decreases the dynamic range, but that's how he was able to capture some of these first color photos and had the series published in Life magazine. And you can actually see him down here with the flashlight in his mouth, trying to get the ice fog off the lens, and there's snow on top of his camera. So that's something that hasn't been solved yet, along with all the electronics and such. You might see somebody doing that exact same thing today. I would have loved to have shown them what a modern CMOS sensor-based camera, digital camera, can do. These are the comparison photos that we can get now with just basically an entry-level digital SLR or mirrorless camera. Some of the photos I've captured from the Yukon, from Iceland, and from Yellowknife. And these are photos from across thousands and thousands of miles of territory. And what you'll see about the aurora is that they occur simultaneously across the entire world. And the scale of them is immense, and they are interconnected. And the behavior in one sector of them, thousands of miles away, will be the same as the behavior in another sector. They're all interconnected and truly a global phenomenon. Speaking of high ISO, if only they could see ISO 28,000, you can now shoot movies of the aurora. This is just a Sony A7 III in Yellowknife, and I pulled it right off the tripod to point it straight overhead to show the auroral curtain right overhead and stretching to the horizon in the bottom left. What you'll notice is the motion. This is real time. This isn't a time lapse. The aurora are not like clouds. They don't sit still. They can move incredibly fast, hundreds of kilometers per second, which can transit the entire hemisphere of sky above you. And so you can see these waves moving all the way to the horizon. And so we have this new frontier of capturing real-time imagery, not just time-lapse photos and not just still photos, because even the still photos exposing to even 1 second, that introduces a lot of motion blur, and the aurora can move so fast, you lose details that a person seeing them from a first-person perspective will say, hey, it didn't look like that when I was there. There was much more detail, much more motion. It's all blurred out. So I think that's sort of the next frontier, is really capturing a lot of this motion that comes with the aurora. So they move fast and they move across thousands of miles in a very short period of time. It's not a very static structure, and the changes can be quite sudden. But first you have to find the aurora. So yes, they're in the sky. Yes, they're in up north, I guess you could think of. Sometimes they come further south. But how are they powered, and what makes them come further south or farther north? And why are some places better than the others, and why is sometimes better than others? The space physics of this is still a hotly debated topic. There's a lot of ongoing research, but one of the towering giants of initial exploration was Shinichi Okasofu from Japan. And he was the person who identified the fact that the aurora are connected all over the globe in terms of their behavior. And he speaks about the earliest days of space physics and understanding these phenomena when they first linked together continent-spanning all sky cameras to all look up simultaneously and captures time-stamped imagery. So he wrote this Space Physics in the Earliest Days as I Experienced Them, as sort of his view as a researcher on how quickly things evolved in the 1950s and 60s. And into the space age, when suddenly you could see the Earth from the other side, not just looking up at the sky, but looking down at the aurora. So I'd recommend that read. It's free and online. The first thing to know is that the sun goes through cycles, almost like seasons. And you may have heard the solar cycle. It's about 11 years. And what is it really measuring? Well, it's measuring how disturbed the sun is in terms of, one metric is the sunspot number, the number of discontinuities, I guess, in the magnetic poles of the sun. It doesn't just have one pole, it can have local poles too. And those are viewed as sunspots. So this is a count of sunspots over time from the year 2000 up until the predicted year 2030. And we are about here, 2022, we're coming up to the peak in 2025 of the number of sunspots. And that's somewhat predictable, but how many sunspots there are going to be is not as predictable. That's another debated topic. But generally, when you have a lot of sunspots, you have an active sun. An active sun tends to spit more particles out into the solar system. And the more particles there are out there, the more likelihood they're going to interact with Earth, and we're going to get more aurora. So it was very quiet for aurora in 2019 because we're close to a solar minimum. There was still opportunity, just not as much. So this is kind of like the odds are ever more in our favor as we move up towards a more active sun of seeing more aurora, especially down south in places like Michigan. And here's a visual difference from NASA of what an active sun looks like, with lots of sunspots and areas of magnetic energy looping out of the sun and back into the sun, versus a really quiet sun like you might have seen in 2019. The energetic particles that arrive at Earth and really drive the aurora ultimately can come from these coronal mass ejections that come from sudden detachments of solar flares from the sun. But often you're looking for something a bit quieter, the coronal hole. And this is a coronal hole. This is a big one that was facing us in 2012. And it looks darker because it is cooler for that particular imaging technique. But a coronal hole isn't actually a hole in the sun. What it means is that the field lines, the magnetic field lines that usually loop back from the sun into the sun, are open, meaning they don't loop back into the sun anymore. Those magnetic field lines just go right out into the solar system, kind of like escape velocity, I guess. And what that means is those particles don't loop back into the sun. They go straight out into the solar system and they might hit us. And that means a coronal hole is kind of like a sprinkler that's shooting more faster energetic particles out into the solar system. And if we're in the way, we have a good chance of seeing more aurora. So knowing your coronal holes, where they are and how often they come around, because they do last multiple rotations of the sun, is a good way to maybe plan some of your aurora hunting. And for decades now, they've been doing hand-drawn synoptic surveys of coronal holes and other features on the sun. And it's really interesting to see that in solar astronomy, there is a rich history of maintaining the way you gather data, because it's been gathered for hundreds of years, and you don't want to have a discontinuity in the way you collect the data. So you also do the old methods as well as the new methods. So you can see here, one of the administrators of one of the Facebook groups for aurora chasers is saying, there's another coronal hole coming around the east limb, meaning the sun is rotating every 27 days. And we know that coronal hole is going to be facing Earth. And 3 days later, there's going to be enhanced solar wind, more energy, and a higher probability of seeing the aurora. And here's what that actually looks like from a simulation model called WSA-ENLIL. This is something you can see at the Space Weather Prediction Center, the SWPC website. And these are top-down views of the solar system. Plasma density emitted from the sun. Again, the sun's rotating, so it looks like a sprinkler looking top-down. And then how those are going to impact planets, for example, Earth here in green. And you can see an increased area of higher energetic velocity is going to be impacting the Earth right here. And you'll see the velocity of the particles, primarily electrons, accelerating from 400 kilometers per second up to 600 kilometers per second as that coronal hole faces Earth. So there is some predictability because that same coronal hole is going to come around again in 28 days, and you can plan your travels around that a little bit. In general, fast wind is better than getting little burps of particles out of the sun because it's more consistent and it sort of charges up the magnetosphere of Earth more reliably and predictably. It pays off more in terms of a predictable system of energizing and seeing the aurora. So we talked a bit about the solar wind and how it comes out of the sun and when. But what happens when it gets to Earth, and how does that trigger aurora? And the answer is a lot of that we still don't quite understand, or at least the models and mechanisms are hotly debated. But one thing everybody can sort of agree on, because it's observational, is this thing called the auroral substorm. And we'll talk about where that name came from and what the components of it are here. This NASA imagery shows the solar wind coming off the sun. And it doesn't just crash into Earth and cause an aurora. It interacts with Earth's magnetic field and couples with it, kind of like when a fridge magnet sticks to your fridge. The particles that come off the sun have their own charge, and they have their own frozen-in field lines, meaning that the solar wind that impacts us has a polarity, just like a magnet. And if that polarity is the opposite, south to north versus north to south of Earth's magnetic field, the energy kind of couples. It's like getting two magnets close enough together. And when that energy couples, the particles get transferred into the Earth's magnetosphere, and they couple with those field lines and compress them behind the Earth. And eventually they compress so much, they suddenly join and release. They kind of short circuit, and that sends a flow of particles into the auroral zones, which are in the north, around the north and south geomagnetic poles of Earth. So that's kind of fortuitous, because if the sun was just shooting particles straight at the Earth on the day side and all the aurora are on the day side, you'd never see it. But because of this coupling and then the reconnection events in the magnetotail that happen just like that, most of the activity is actually on the night side, and that's where the particles flow into the auroral zone and collide with atmospheric ions like oxygen, nitrogen, and create the glow of the aurora. And this mechanism, again, is still debated, the nuances of it. This is a simplified 2D model, but the 3D models and the debate around that are ongoing. So that's why you see the aurora on the night side. And here's one of those auroral ovals. This is looking straight down on the geographic North Pole. And on the left side is a probability of seeing the aurora. Again, it's that kind of donut or crown that sits on top of the geomagnetic North Pole, which is offset from the geographic one. And it's most bright in the middle of the night on the dark side. And that's because the particles are flowing in from that side, not from the day side, because of that reconnection on the night side of Earth. And the difference here is the probability of seeing the aurora when it's a very low power going into the geomagnetic field. In the case of the left side, it's 10 gigawatts, which is about as much as, say, 10 nuclear power plants. And on the right-hand side, it can be something like 100 gigawatts. So an order of magnitude higher energy. And you can see the probability of seeing the aurora goes up dramatically to almost 100% in many areas. But also that auroral oval expands southward. And that's why when there's geomagnetic storms on the news you might hear about, you'll have a higher probability of seeing the aurora south, because that excitation, that intrusion of particles into the atmosphere is indeed further south. Basically, this auroral oval grows southward. And here's an example of how magnetism and what you see visually really are one-to-one coupled. This is the magnetic field traces in Yellowknife at one of the magnetometers there. And this is what you actually see at that same time. I've synchronized them so you can have a look. And this is one of those substorms. As soon as that magnetotail reconnects, it releases that energy back into Earth. So that's the reconnection event. The magnetometers see a big disturbance in the magnetic field, but at the same time, visually, you will see the sky fill with aurora. That's called the breakup phase. So it's just lines of aurora that are relatively quiet. And then suddenly you'll have a big explosion of color and vibrancy just above you. So that's really what the heart of the substorm is in terms of photography and what you're looking for. In other words, if there's a night of aurora and you're going out to see aurora, you should be patient because there'll be a lot of quiet times. And then suddenly all at once, just like a fireworks display, it'll start up, get very intense and have this breakup phase. And then it moves into another phase where it's basically recharging itself and it has a different characteristic. And it might do that for a few hours and then have another sort of charging up, reconnection of the magnetotail, and then another one of these breakout phases. So a lot of people who go aurora hunting, they'll see this once at night and go home, but it's worth staying out because there might be 2 or 3 or 4 of these during one night of viewing. And researchers have created sort of like the equivalent of a seismogram for earthquakes. They have something called a kilogram for encoding a whole night's of aurora. This is an all-sky camera facing straight up with the zenith in the middle of the image, north to the north, south to the south. They take a slice over time right from north to the south because auroral activity tends to be mostly east to west when you're looking straight up. And they put these slices kind of like books in a book, or the spines of books in a bookcase from left to right, showing a whole night's of aurora. And you can actually see very quickly, if you look at a bunch of kilograms, whether there was a substorm right here, or whether there was a recovery phase where the whole sky is filled with more diffuse aurora. And very quickly, they can look at days and weeks and months of data, almost like looking at a big bookshelf and be able to pick out where the activity was. So these kilograms are a unique visualization for aurora science that's also used by aurora hunters to identify where the substorms were and what a typical night might look like. They're also good at identifying cloud cover, full moons, and so on. So let's look at one of these kilograms for one night, going from sunset right here on the left, all the way through midnight, and then to sunrise. And you can clearly see that there's periods of activity, and you can break these up approximately into 4 different substorms that night where things were quiet, then suddenly the whole sky fills with aurora. And again here with a second substorm, and then one substorm that seems to have multiple ones layered on top of it. Again, nothing is straightforward when you model it that way, but you can see it's definitely worth staying out from, say, 9 p.m. and then 11 p.m. and then 1 a.m. And then finally, one more substorm closer to the morning. So yes, if you've traveled all the way to go see the aurora, don't go to bed early is kind of the takeaway from that. And understand that the aurora don't go on all night. They come in fits and starts of amazing color and activity, and you just have to be patient and be ready for it. When you start to see them brighten, get out and take some photos and get ready with your cameras, because they might turn into this sky-filling breakup phase of the storm. Now, what do you actually see when you're looking up at the aurora? Well, it's the particles of in the atmosphere glowing at various altitudes from, say, 60 kilometers and upwards. So the atmosphere is a very diffuse and sparse at that altitude. The species of gases are, of course, like nothing we breathe down here. There's a lot of ions. There's a lot of atomic oxygen, things we don't get closer to the surface of the Earth because the sun tends to energize them and prevent them from turning into things like molecular nitrogen or molecular oxygen closer to the surface of the Earth. But each of these absorb the energy from those electrons that are cascading down, and protons, and then they emit just like a neon light at specific frequencies. And atomic oxygen at 557 or 58 nanometers is the predominant one we see, partly because that's the one that's most energized, but also because our eyes are most attuned to seeing green at night. So I put together this little animation to just go through what some of the species are that make up this auroral curtain. We sort of think of aurora as this ghostly green glow, and that is from about 80 or 100 kilometers up to 250 kilometers. And that's caused by atomic oxygen glowing and releasing, or getting energized by these electrons and then releasing photons at 558 nanometers approximately. And they do that with a half-life of about, I believe, 0.7 seconds. So it's relatively quick. They absorb the electron and they emit within 0.7 seconds as a half-life. So you can see quite a bit of motion and activity in that curtain for this green altitude, or this green emission. But there's a lot more to it than that. There's basically other species that can glow as well. Molecular nitrogen, it tends to glow below the atomic oxygen. If you have high velocity electrons or high kinetic energy in the tens of kilovolts, it can make it, those electrons tend to make it further into the atmosphere, and they start to hit the molecular nitrogen species, which form a sort of pinkish, purplish, fast moving border on the bottom of the atomic oxygen. That's something that people tend to say ooh and ah when they see it in person, when the green suddenly has these extra lines of animation across the bottoms of them. And that's a much faster emission rate too, so it seems to move much faster in person. And this tends to blend a bit with the atomic oxygen above it. These aren't definitive lines. They blend, and that's why you see aurora in so many different colors. The next species is ionized molecular nitrogen, which goes all the way up to 300 kilometers. And you can see that that is overlaid with the green. So it actually makes the green a bit paler because of the way the light mixes. And those species go up to a much higher altitude. And that's why maybe if you look at Chris's background, Chris Nichols' background, you start to see this Aurora mission is looking a lot like his background. We've got the green on the bottom and transitioning to sort of a purple at the top. But we're missing that red that Chris has in his background. So where is that? Well, that's atomic oxygen, and that's at even higher altitude. And it tends to color in with the blue of the ionized nitrogen emission lines, and it gives this amazing purple transitioning into a deep red. And our eyes aren't as sensitive to that, and it doesn't happen as often, but when there's more solar wind density at slower velocities, it tends to get caught up higher in the atmosphere, and it excites the atomic oxygen more, and it'll give you those deep reds, as opposed to the fast moving electrons, which will penetrate all the way to 80 kilometers and give you those fast moving purples all the way at the bottom of the curtain. And in places like Michigan or in Nova Scotia, where I am, because of the curve of the horizon, we tend not to see the aurora as often, but when we do, we see mostly this beautiful red transitioning into purple with maybe a little bit of green on the horizon. And that's because when the aurora are visible, they tend to be highly energized and excited. And then you see the tops of the curtains, which tend to be red. And if you're up in a place like Yellowknife, where you see the aurora almost every night, even when there's not a lot of energy, they'll be mostly green. So that's one advantage of living south, is you will see this transition from green all the way up to red. I wrote a simulation, a web simulation at kpfox.com, where you can actually see some of these working, and you can change the amount of energy coming into the atmosphere to see how the aurora might change, all the way from just quiet, slow-moving green up to highly active with lots of reds. It also takes data from the Space Weather Prediction Center and reports the KP index, which is sort of the overall energization or the energy level in the Earth's magnetosphere. And it's a good analog for knowing how active the aurora are going to be in general. So please feel free to check that website out on a sort of daily basis. And there's also some narration in the top for kids if they're interested in learning a little bit about the aurora. And of course, you can play with the aurora and change how active they are with this simulation. It also gives you the moon phase accurately too, so you can see how much light pollution is coming from the moon. We do have a big community all across North America. One example is the Alberta Aurora Chasers. They have people that will capture with their phones images all the way, in this case, from southern to northern Alberta. This is about 1,000 kilometers. There was this unique kind of Olympic rings structure that had formed, and everybody thought it was amazing who saw it and took a picture of it at about the same time. I believe it was 10:15 p.m. local time, and they all posted it on the Facebook group. And I took the opportunity to connect all of their photos all the way south to all the way north, just to show that these structures are something with parallax, and they are 3D structures in the atmosphere that you see. When you talk about an auroral curtain, you really are talking about vertical structures hundreds of kilometers deep that have a 3D structure. And you can see when you put these images in sequence, moving from north to south and south to north, the parallax even across just one province, so 1,000 kilometers. So that also speaks to the idea that there can never be enough aurora photographers, because they can put all of their images together and learn something new and contribute to the science. So yeah, it's hard to get the parallax on a nebula perhaps, but with the aurora, it's not as hard. So let's look at just forecasting quickly. I mentioned the KP index, and what that really is an old scale, but it's still, I think, valid, of measuring a whole bunch of magnetic activity from different stations across the world. KP0 is very quiet conditions, all the way up to KP9, which only happens once every few decades, which is extreme storms, extreme activity, and extreme aurora that you might see all the way as far south as near the equator. Generally, what you'll find is that auroral activity moves somewhere between a KP0, and then I think most recently it got up to a KP5 or 6 last month, and it moves around in those areas. The more active the sun, the more energetic the sun, the better chance you have of moving up into these areas of KP6 and 7 and so on. So it's a really good indicator. If somebody says, oh, it's going to be KP4 conditions tonight, you have a fairly good chance of seeing the aurora, depending on your latitude. And that's generally measured in 3-hour intervals with bar graphs. This is from NOAA and the Space Weather Prediction Center and spaceweatherlive.com websites. You can often see these short-term 3-day forecasts, and then a longer-term 28-day forecast that's based on the idea that what we saw 28 days ago in the sun, we'll probably see in another 28 days. So we can predict that there'll be, say, that coronal hole coming around again in 28 days, causing more auroral activity, in this case up to KP4. This is fairly quiet, and they've colored it green and yellow for that reason. However, when it does get up to KP7, this is in Ottawa, which is about at the same latitude as Michigan, you will see the aurora on the horizon. And I took this before they put in LED streetlights, so there was still a chance to see things from right downtown. But you can see there is that correlation on the northern horizon. If the KP index says we're up at KP7 or so, then you are going to see aurora further south. And these conditions can be reported on sort of a calendar for long-term prediction. This is from the Alberta Aurora Chasers. They put together a calendar every month. And you'll see, like on November 18th here, we have a fairly okay chance of seeing aurora further south than we might on, say, November 13th. And this is something that the National Weather Service will actually put out, is a strong solar storm possible. And this is one from August 18th of this year. And the reason they put this out is not just because they want you to go out and photograph the aurora. It also means that there's going to be problems with the ionosphere, with the geomagnetic conditions being disturbed. You might have induced currents in power systems, which actually caused a huge blackout in, I believe, 2003 in Quebec and parts of New York. Radio operators are very conscious of this, especially ham radio operators. And you might even have GPS navigation problems. So the aurora are nice to know about to photograph, but solar storms are a serious consideration. And if you want to read up on something on Wikipedia, read up on the Carrington event, which was, had it happened today instead of in the 1850s, it might have caused a lot of havoc for all of our digital systems that we rely on. Those KP numbers can be reflected in the probability of how far south you'll see the aurora. And if you look at Michigan right here, it falls between the boundaries of KP5 and KP7. So if you hear that the aurora condition, or if you hear the geomagnetic conditions are, say, KP6 or KP7, if you go out to the looking north, you have a good chance of seeing the aurora, even as far south as Michigan, if it's a dark night. And here's an example of how far you can actually see the aurora. This is the Worldview system from NASA. It's a really interesting website, but you can see November 6th of last year, we had a KP4 level in the aurora, which are seen here sort of in infrared, came as far south as northern Ontario, which is over 1,000 kilometers from northern Michigan. And 1,000 kilometers is the extreme limit of what you'd be able to see on the horizon. So you wouldn't see the aurora that night. But then November 4th, 2021 had a KP78, which is also called a geomagnetic storm, G3 or G4. They're just slightly different scales, I guess. But that was only 500 kilometers, the edge of it was 500 kilometers north of Michigan. And then there was a lot of activity that you can just make out even further south than that. So if you're in a dark sky area looking north in Michigan, that night you probably would have seen something. So it just shows the variety of activity that can happen and how it correlates with this KP index, which you can follow on the Space Weather Prediction Center. When it comes down to who's actually looking at this information, we have the Discover satellite, and we have two other satellites at the L4 and the L4 and L5 Lagrange points that are seeing both sides of the sun. So they can detect when there's specific emissions like a coronal mass ejection, and they're actually in the path halfway between the sun. Well, not halfway, they're sort of like in between directly the Earth and the sun. So they will see an uptake in particle velocity and density a few hours before it hits the Earth. So aurora chasers also have this Discover satellite, for example, to keep an eye on particle counts to know, oh, something is coming and it's going to energize Earth's geomagnetic field, and that in turn is going to cause a higher probability of aurora. And this is what that information really looks like. Again, this is the Space Weather Live website, which a lot of aurora chasers rely on. They look at these graphs right here. They look at the solar wind speed to get an idea of how much energy is coming at us. 400 is fairly typical. 600 would be extremely fast, and that's kilometers per second of the solar wind. And just like a baseball, the kinetic energy really matters in terms of energizing the atmosphere and creating those emissions that we can see. Solar wind density is the other side of it. Is what is the particles per second? 5.9 is relatively low. It can go as even lower than that, but it can go as high as 10 or 20 particles per centimeter cubed. And when you have a lot of particles at a slow speed, that's when you tend to see those red aurora further up in the atmosphere. Correspondingly, when you have maybe a lower density, but a higher speed, you'll see some of those purple aurora below the green that move very quickly. But one of the things that really matters most is the polarities aligned, so to speak. Is the interplanetary magnetic field facing south, red, or north? When it's facing south, it can couple with Earth's geomagnetic field, and all that energy gets transferred much more readily. If this interplanetary magnetic field is facing north. As you can see just on the edge of the screen, it's going north. All of a sudden, it's like the Earth has shields up, like the Enterprise. Those particles are going to tend to be deflected around Earth's geomagnetic field as opposed to coupling with it. So if I had to look at any one number for a night of aurora chasing, I'd really look if the geomagnetic field is facing south and red as opposed to green and north. And when it's south and red, I'd tend to want to go out and chase the aurora a bit more. But what do you chase them with? Aurora hunting equipment is interesting and maybe a little bit different than what you get for deep sky objects or planetary imaging. Because the aurora moves so fast and are a full sky phenomena, you're really looking at applying photography disciplines from astrophotography, which is knowing your camera in the dark and when it's cold and when you have gloves on, knowing every button, and doing long exposures, with the idea of a wildlife photographer, meaning the aurora can move extremely fast and you have to be ready with a ball head tripod or something similar to recompose very quickly, because what was in front of you a second ago might now be directly above you or behind you. So you can be waiting for hours and then suddenly have all this activity around you, and your carefully chosen spot doesn't matter anymore because everything's happening behind you. And finally, landscape photography is actually a big part of this. As you can see in this photo I took in Marsh Lake in the Yukon, that's a beaver pond, to get some really good reflections and some interesting trees in front. You'll travel thousands of miles for a dark sky that's open for viewing, but then you'll want to put a really nice tree right between you and the aurora just to make a good composition. If you just have photos of aurora, it kind of looks like abstract art. There's no context or anchoring to it for an average viewer to understand what it was like to be there. And so you have to have elements of really understanding foreground and framing and really putting the viewer in the photo. Pointing your camera straight up is usually not going to be anything that looks different than a tie-dyed t-shirt unless you have some context of a human scale. The other thing about aurora is it's very much your personal sky. I added this shot for this presentation is when you're aurora chasing, the photo you capture, nobody else is going to see that same photo, that same moment. It's like a fingerprint and totally unique. Things can move so quickly. The framing is different. People are in different locations all around the world. You might be the only person to have ever seen that particular formation at that moment, and your photo will be unique. And that's something that's very exciting to me, is that you aren't replicating a photo that somebody else took and trying to make it a little bit better, a little less noisy. You're really out there to capture something that means something to you, and it's not going to look like anybody else's aurora photo. And to me, that's a really unique thing about this kind of photography in the night sky. It's always changing, and it's always surprising. This is a sequence from my camera. You tend to take time-lapse photos, hands off, on a tripod. And this is 1 second exposures in real time as they were captured at Kluane Lake National Park, looking north over Kluane Lake. This is in the Yukon. It's sort of in line with, say, Fairbanks in Alaska in terms of latitude. And you can see here how quickly this gigantic formation, this swirl, formed and then dissipated. So I had my camera taking pictures here thinking, oh, is this a good way to point my camera? I don't know. But then suddenly everything just came together. This is in real time. And the formation here, because of sort of they still don't quite understand how these formations form curtains that then curl in amongst themselves. But it's an interaction of the magnetic field, the currents flowing, and charged particles. So they self-interact to coil themselves around each other. You have to be ready, and you have to have sort of an open mind about where you're going to point the camera and what you're going to capture. You can also see that we went from sort of an underexposed photo to overexposed. So we went through 5 or 6 stops of exposure very quickly because the aurora can brighten up and dim up so much. Finally, a thing to take away from this sequence here is that the aurora image that we're capturing here goes from almost overhead to almost 1,000 kilometers in the distance, well, maybe 500 depending. And so the aurora in the bottom right are actually a deeper green, kind of a more emerald green or a yellower green because of the same atmospheric scattering you get with a sunset. The aurora far away will appear like they've been shifted towards warmer colors because of the atmosphere. You're generally shooting with a consumer SLR mirrorless camera, either a full frame or a APS-C camera. So anything you think of like a Canon R series or a Nikon or one of the Sonys or a Fuji, any of those where you can replace the lens is going to be a great camera for photographing aurora. But what you really want to choose is a good lens. A good lens is a bright lens. I put together an article about what lens I should get for the aurora. But here's an example of how much the exposure, the amount of light a lens can let in per unit of time can vary all the way from an f1.4 lens, which is extremely bright, it's sort of a high gain in the top left, all the way to an f3.5 lens in the bottom right. And that's the kind of lens that you get if you got the kit lens with an SLR camera. They usually put in an f3.5 zoom lens. And you can see how much darker it is. It's very much noticeable. You can still get results, but the brighter the lens is, the shorter your exposure time. The shorter your exposure time, the more detail you're going to capture and the less smearing you're going to get, because the aurora do move potentially so quickly. And that higher level of detail is really what you're seeing in the first person that gives the aurora so much character. It's also a very wide angle kind of activity, partly because you're trying to capture a little bit of context. In this case, these are the tide pools around a place at Akranes in Iceland, which is on the west coast of Iceland. And they have a lighthouse there that we'll talk about a bit later. But I put together this little sort of cheat sheet for what you would capture versus what you would miss, depending on the focal length of the lens on your camera. If we look at full frame, you really want something as wide as 14 millimeters if the aurora going right overhead. If you're further south and the aurora tend to be just on the horizon, you might get away with something like a 50 millimeter lens. And that's in areas like where I live, or Michigan, because you're pointing way at the northern horizon and you're not worried about what's further above you because that's where the aurora are. But if you're going on an aurora hunting trip to a place like Iceland or Yellowknife or Fairbanks, you probably want to go and rent a very wide angle, very bright lens. And I put the equivalents here also for an APS-C type camera like the Fuji films. That's generally around a 10 millimeter lens. So here's an example of sort of putting that all together. Here's Yellowknife during a KP3 geomagnetic activity. So there's quite a bit of motion. Setting up on a tripod and taking a time-lapse photo and joining that into a time-lapse. And I was using a Sigma 14 millimeter f1.8 lens. And that was on a Sony a7 III full frame body. And that's sort of the cheapest A7 you can get. And it still is a wonderful aurora camera. In fact, almost any camera these days is wonderful for aurora photography as long as the sensor is APS-C or larger. And I turned off the noise reduction in the camera. There's dark frame subtraction and there's noise reduction, but both of those take up processing time and you miss getting these sequences of time lapses if the camera is doing something in between each exposure, and your time lapses are not smooth in that case. So one thing to remember to do is to turn off the noise exposure, or at least I do that for my aurora photography when I'm doing these time-lapse images. And don't just try and capture one image. Have the patience to stick to capturing maybe 50 or 100 or 300 images so you can make these wonderful movies that really show the motion and the behavior of the aurora. And that means sort of ignoring the temptation to go and reframe your shot when something amazing happens to the left or the right. You have to make that judgment in real time, sort of like a quarterback. What are you going to do next? Are you going to keep getting your nice time-lapse sequence, or are you going to reframe and start a new one? So again, that goes back to being sort of like a wildlife or landscape photographer. You have to think quickly. Finally, you'll notice that going up to Yellowknife, yes, you'll see aurora every night, but you might not see all the colors every night because the KP level is a bit lower, and so you're mostly only seeing the green activity. Here's the kit that I took on one of my trips recently. You bring your computer, you bring your tripod with a ball head so you can quickly recompose, intervalometer or built-in intervalometer for your cameras so you can get time-lapse sequences, and those very wide-angle lenses. I tend to really keep it light as much as possible. So that means maybe 2 camera bodies and setting them up in different directions and just having that one wide-angle lens each. I also bring a lot of things for safety, and this means bringing a hot beverage, tea, bring your passport in case somebody asks why you're out at night on the side of the road. You want to say who you are. Headlamp that has a red mode is kind of vital for setting up. And of course, bringing some hand warmers or some way to keep warm. And while you're out there, you're going to want to back up your photos because you might be taking thousands of photos a night. Be able to back those up with the computer and view them is really quite important. But this is all you need for an aurora hunting kit. You don't need sky trackers. You don't need a large reflector telescope or anything like that. You're very much almost like a sports photographer. One thing you'll note here is I bring hockey tape, which works well in low temperatures, which tends to be where you get the aurora photography. And that's to tape things like hand warmers to the cameras to keep the batteries warm, because some places like Yellowknife can get down to -40. And your lithium batteries don't really like that. The time that they last is reduced greatly. So you often have to think about keeping your cameras warm in some way. One other thing that is interesting about aurora photography is there's very much monochromatic light or very narrow emission spectra. So if you accidentally leave your UV filter on any of your lenses, you're going to get a Newton's ring interference pattern right in the middle of every single photo you took on your trip. So as much as it might pain you with a very expensive lens, you have to take off the UV protective lens filter. Otherwise, you risk getting these Newton rings due to interference within the layers of that filter. And there's a picture from one of my nights where I learned that the hard way. One of the biggest pieces of equipment for chasing the aurora is your rental car. There are places you can travel where they'll just put you up in a lodge and you can go out in the back porch and take photos until you get cold and then come in for a coffee. The kind of aurora chasing I do tends to be rental car based. You fly somewhere, you rent a car, and you treat that as your base, because now you can drive out from underneath cloud, which tends to be a very effective way of getting a clear sky, is just driving 10, 15 miles. It also acts as your emergency shelter. I never turn my rental car off because of the kind of places you go. You don't want to have it not start again when you're really quite cold and you can't feel your toes and fingers. It also acts as your tour bus. You can go away from the beaten path. You're not bound to being around other people with their headlights on or getting the same photo as them. You can really explore by having your own rental car. And of course, it acts as a battery pack to charge your stuff, a good closet and a good kitchen to keep your coffee warm. These are some of the license plates, I guess, from some of the travels. But I like chasing aurora with having a rental car available, definitely, for these reasons. So we'll talk about this little trip diary from 2019, 2020, and then I added to it for this presentation to see what's been going on since then. The pandemic threw a damper on traveling, but things are picking up again. So we'll talk a bit about bringing all this stuff together and what the results can be. Never miss an opportunity to grab a window seat on the north-facing side of your airplane. When you're traveling out to see the aurora, you have a very good chance of seeing them on the way there. And this is a photo out of the north-facing side of the aircraft, just over Labrador on the way to Greenland. I think I was flying to Iceland for this. And the whole night there was these amazing aurora off the wing reflecting on the aluminum of the wing. It was pretty stunning. And I found it kind of interesting that a lot of the passengers had their window shades closed because they wanted to catch up on their sleep before they got to Iceland to start looking at the aurora. All they had to do is open their windows and see this. So you have to be ready no matter what stage of the travel you're in. And just flying across east to west in Canada or to Iceland or to Europe where you're going over the poles, you stand a very good chance of seeing the aurora. So If you're interested in that or have the opportunity, you're going to be on a flight anyways, choose the north-facing side of the plane and be ready with just your phone or your camera equipment. One trip I like doing a lot is Iceland, because the coast and the geology is so varied. The temperatures are very moderate along the coast. You go to Yellowknife, it can be minus 20 or 40. You go to Iceland, it'll be minus 2 or 3, and you'll still have water to catch reflections on, things like lighthouses, beautiful geology, and the ocean. Going north of Reykjavik, the capital, there's a smaller town that I like called Akranes, and they have these tide pools, which we saw earlier, near one of the lighthouses there. I think it's the oldest still functioning lighthouse in Iceland. And I just sat around in the tide pools, hopping between rocks and setting up the tripod, getting photos all night. A lot of the Aurora photographers stayed kind of on the walkways right near all that light pollution that you see in town to the bottom right. But by getting out onto the rocks, even just 100 feet or so, or 200 feet, suddenly you have a completely different vantage point. And although there's that temptation to point the camera straight up and capture all you can, you have to think about, am I getting a photo that really has a sense of place and scale? And that means bringing the human into it. And that means capturing a bunch of the landscape around you. Iceland is also very good for just getting around, renting cars, driving, restaurants. I'd recommend it as a place to go to visit, because even if you don't see the aurora because of weather, there's still plenty of other things to do. And it's very tourist oriented. And at the same time, you don't feel like a tourist, you still feel like an explorer because of the low density of people and the huge opportunity to see all kinds of different things. Here's another photo from that same night. Later on in the evening, after midnight, the aurora tend to take a different form than they do before midnight. And that's sort of a characteristic of the way the auroral oval behaves throughout the night. So later on, you get these kind of rivers of light, and you get these striations of pulsing aurora. And so I framed it to capture both the lighthouse and some art that was done by one of the lighthouse keepers. I believe they also use that lighthouse as a concert theater because the acoustics are amazing. So they'll have, say, a string quartet come in there and play. So it was nice to meet the lighthouse keeper and take his photo and give it to him, because nobody had ever taken his photo with the aurora in front of his lighthouse. And often when you see the aurora, people are taking pictures of themselves with the phone, and it's not too much effort to take a picture with your sort of tailor-made aurora equipment and then email it to them later, and they have a wonderful memory that's much better than what they would have captured just with their phone. So I've made that sort of a good luck habit of going on these travels, is sharing my time with other people. Moving down to another part of Iceland, this isn't that far away. In fact, it's closer to the airport. This is some of the amazing geology along the coast, and they have these ragged, interesting, rocky outcrop islands further out into the coast. And this is much later in the evening. All the tour buses had gone home, but as we discussed earlier, you stay out because the aurora can get very interesting after 2 or 3 a.m. And one thing the aurora do is they tend to get these ragged, pulsating forms. Instead of a distinct curtain that's connected together, it breaks up into little tatters of curtains, and they tend to pulse, almost like if you've ever seen an octopus or a cephalopod. Is it a cephalopod? Yeah, like a cuttlefish. They have the pulsing skin. And you'll actually see that in the aurora at a high frequency, sometimes as high as tens of hertz almost. And you think, how can the whole sky coordinate like a bunch of pulsing zebra stripes? But that's, again, part of the science and the research that goes into it. And that's the kind of thing you see in the morning sector when you stay out past midnight, is these ragged forms that tend to pulsate in unison. And this is a photo of that effect. And you can also see Andromeda in the extreme top left above the V in Never, as well as the line of the galaxy. So even though the aurora are a little bit fainter, that gives you an opportunity to really capture the star fields behind them. Iceland's known for its waterfalls, and Gullfoss is one of the most notable ones. This is a case of staying late and waiting for the parking lot to empty out. This one, and because I wanted to really compress the view of this gigantic waterfall network, I used a 50mm lens instead of a wide angle lens and went, I'd say almost a third of a mile back from the waterfalls to get this photo of the clouds encroaching on the aurora and then the waterfalls too. And although clouds are kind of your enemy with a lot of photography of the sky, they also add an additional layer that gives a lot of depth to aurora photography. So as long as they're not completely obscuring things, they really give you that sense of layer upon layer of interesting interaction. And of course, the aurora do light them up too. After Iceland kind of went the other direction, and this is the Yukon, right near the Alaska border, there's a park called Kluane National Park and Reserve. And if you keep driving south of this, you'll end up in Skagway, Alaska, where a lot of the cruise ships go, and northern BC. Again, this is a wonderful place to drive and look around because there's mountainous terrain, there's lakes, there's some good restaurants, and Whitehorse is a wonderful town, and just some great people and some lakes to also photograph from. I like Kluane Lake because it's gigantic and faces north. And the road into Kluane Lake goes along this beach on the south side of it facing north. And the weather was relatively mild in September. And I and maybe one other aurora photographer were out all night capturing this. And you can see here why it matters to have a little bit of cloud in the view. It really gives that idea of the aurora are above you, but not too far above you, but they're still above the clouds. And it gives that real human sense of depth. And we're seeing here those layers of the green, of course, and then the purples above it from the molecular nitrogen, and then the deeper colors of green as you move towards the horizon due to absorption of the atmosphere, preferentially of the blue as opposed to the red. And here's a still photo from that sequence I showed earlier where the auroral curtain, when it gets energized, starts to twist in on itself. And I really like this picture because it shows a sense of scale of one of these giant sort of swirls of the curtain twisting in on itself until it twists too much and sort of breaks up. But each of those rays that you see in the light is actually a smaller twist. So it's almost like fractals down to hundreds of meters of scale and up to hundreds of kilometers of scale. That same idea of the auroral curtain twisting on itself, and each of those twists is of light. And so it amplifies some areas to form these ray appearances to the eye. And that's basically where the aurora have twisted in all kinds of scales from hundreds of meters up to hundreds of kilometers. Moving back towards town and then south of Whitehorse, there's a very famous camping spot called Marsh Lake. And there was a seasonal walkway across a beaver pond behind the campgrounds. And they have these wonderful, very thin trees. And I really framed around those trees and the very calm water in the beaver pond to get some all-night aurora photos. Setting up on a wobbly bridge and trying to get 5-second exposures is not easy. You have to be perfectly still. And the beaver pond was still populated, and the beavers do not like when you hang around at night. They tend to slap their tails really loudly on the surface of the water to scare predators away. So I'd be photographing in perfectly still environment, no wind or anything. And when a beaver slaps its tail on calm water, it's like doing a belly flop. It sounds like a gunshot. And so you're trying to stay still, knowing that in a few seconds, there's basically going to be this firecracker going off right next to you from these angry beavers. And so that was kind of an unexpected side effect of getting these photos. But I guess you just have to kind of be ready for all kinds of eventualities when you're out at night. Yeah, oh yeah, and there was the time the police checked out my identity when I was in Norway too, because they're wondering why somebody would pull over on the side of the road. So just to photograph aurora, but you always have to be ready with your explanations and your story. And yes, I'm taking pictures of the night sky. As normally people don't stay out till 3 a.m, freezing themselves to death to take photos in a fairly isolated place like this. But if you want the photo, that's what that's what pays off to invest in that kind of getting out there away from the beaten path. On that same night, I captured the aurora going right overhead. This is something we might not see in where I live now or in Michigan. But the aurora do get right overhead, and it is a curtain that has a finite thickness. It's maybe a few kilometers wide. And when you're directly underneath that curtain, it kind of looks like warp speed on the Enterprise. All those rays, they converge at the geomagnetic zenith, and they come at all angles out and around you. So as you get right under the curtain, it really is like being under a physical curtain, and suddenly all the rays go from being in one direction like this to being right overhead, and they're coming right at you. It feels like you're falling into them. And this is called the corona or crown. And a lot of aurora photographers, they really go north to capture this new view of what happens when suddenly you're right inside the aurora. It's not just something on the horizon, it is right above you and all encompassing. And that's really a different feeling because it can move so fast, and the microstructure you can see and how fast it moves is almost beyond belief. You have speakers from the Royal Astronomical Society. One of them is the Calgary chapter, and they actually, in collaboration with the University of Calgary's Auroral Imaging Group, discovered sort of a new phenomena called Steve, or which is called Steve. And this is me capturing Steve from that same beaver pond looking south. It's sort of a different kind of aurora that isn't aurora. It's a different kind of emission that comes with these green picket fences sometimes associated with it. And that's only recently been discovered and characterized, and now the debate goes on about what causes this new kind of aurora, because as you can see, it doesn't look like the regular aurora. So images like this, they do make their way back to the researchers and get added to databases, and papers are published about that kind of information. So aurora chasing isn't just for the nice pictures. It makes sense to make sure that you have calibrated the clock on your camera, and you know where the longitude and latitude of your images were and what the focal length of your lens was and so on. Because some researcher might come and say, hey, I like your photo. Somebody took a similar one 100 miles east of you, and we want to combine them to make basically a triangulation of depth and scale of what is the distance between all of these picket fences. So one thing you can do to be an aurora chaser is also be a citizen scientist and make sure that you capture images which can be scientifically useful by having the proper location and timestamp on them. Moving back to sort of the Canadian capital of aurora hunting is Yellowknife. It's one of the largest cities up north. And I was there for a ice carving competition. So I just brought my smallest APS-C Canon camera. It's basically the shirt pocket type. And I was staying at a hotel there. I didn't have a rental car because it was sort of a business trip. And I was at a hotel right by a Pizza Hut or a pizza joint, and the huge amount of light pollution from some sodium lamps, which lit up this tiny forest behind the pizza place. But nonetheless, there was amazing aurora right in town that I photographed, and had a great time just smelling the delicious pizza and getting photos in the middle of town of the aurora. Had I not brought my camera, I wouldn't have this photo. And so it always makes sense to at least have a small camera with you. If you know you're going for a business trip or something, be ready always. And a lot of people commented, oh, how did you get the colors of those trees? Well, that's all light pollution from the hospital behind the trees and the helipad and its sodium lights lighting up those trees. So another place in Yellowknife that's worth traveling to is you rent a car in Yellowknife and you travel along this road that's called the Ingram Trail. It stretches across a whole series of lakes that get frozen in the winter, and you can drive your vehicle onto some of the lakes because the ice is so thick. And this is the kind of thing you can see on those lakes when you're all alone. So there's a time-lapse sequence of the auroral curtain sort of twisting and turning. there's a bit of ice fog because it's so cold, and the ice fog tends to make the stars more diffuse, but you can also see their color as well. So I really like these photos because the stars really had more color to them because of the diffuse ice fog, and also because you could really see that vanishing point of the aurora. And again, you put some foreground object to make it interesting, not just a bunch of frozen ice. Put a picnic table there and called it like a feast for the eyes. So keeping a photo interesting is something to think about. Whimsical is fine, I think, especially when you're looking back on it many years later. Keep it interesting and keep it fun too, and always put the human in the photo. As the lakes freeze further up north, this is another area of Ingram Trail, and you'll see a familiar shape here. It's sometimes called the mothership, but you remember from the photo of Kluane Lake where we had, again, that spiral that forms when the auroral curtain gets active and starts to twist on itself. And this is much further in the horizon, almost behind the horizon here. So I find it interesting that you'll start to see repeating patterns and some characteristics, regardless of where you are or what country you're in, or maybe the time of year. You'll start to see these patterns emerge throughout all your photos. In this case, this big spiral here, which has a lot of visual impact, I think. Another element of traveling with the aurora is that you might not always see the aurora, and you have to just not stay in your hotel room and catch up on your sleep. Go out and explore a bit, especially if you're going to a place like the Yukon or Fairbanks or Churchill, Manitoba, or Yellowknife. In the case of Yellowknife, it has, going there in April, has this unique benefit of being able to drive right out onto the lake. And there's a shortcut highway that goes across the lake from Yellowknife to another small town. And this ice highway, when the wind blows for a few days, gets polished, perfectly transparent. And so I put my rental truck on the side of this highway, which is like 16 lanes wide, and took this little video of what it is like to drive on an ice highway. So right as you look into it, you can see the purity of the ice, and you can see the discontinuities of where the different ice layers froze together, and how the bubbles froze on their way up through the ice. And the whole entire highway is like this for several miles. It's like driving on crystal. And I found that just amazing. And that was from looking down instead of up, and just always having an open mind and being ready to see what is out there. Because a lot of the times the places you go to see the aurora are places that are there by necessity, either through mining in the case of Yellowknife, or the gold rush in case of some elements of the Yukon, like Dawson City. And there's a lot of culture and heritage behind that. And it's worth sort of treating aurora chasing like adventure travel. So what happened during the pandemic? You can't go where you want to go, but there's aurora chasers everywhere. So I thought I'd take some time to address a big issue that I had with aurora, and that was you can't be everywhere at once. And I wanted to make cameras that I could just very quickly set up and deploy while I was taking pictures of the aurora, or that I could give to other aurora chasers who are up north and I couldn't travel up there because of travel restrictions. And these cameras would gather the information that I wanted. So I came up with this idea of putting one of those small APS-C cameras with a Raspberry Pi computer and a battery and a GPS into a combined unit that would sit on a tripod and capture all the time lapses automatically. And these would capture an all sky view like we saw earlier, the entire sky. You don't have to worry about where you point the camera because it's already seeing the entire sky. There's nothing behind it, everything's in front of it. And while it captures these time lapses, you can take your artistic photos with the confidence that you're not really missing anything. So I went and tested this out in Dawson City, speaking of the gold rush, last fall. There's a place called Midnight Dome, which is a sort of a campsite almost overlooking the valley of Dawson City. And it's just wonderful. It's above the fog that forms in the river valley. and there's no light pollution there, and you can just spend the whole night looking around. And this is the kind of thing that the aurora I captured. So this is looking straight up in the center of the image. And you can really see those vivid magenta pinks at the very base of the curtain because there was the higher energy electrons. And you can see how they really trace out a path that the green then follows behind. And everybody that was there at Midnight Dome at the time was basically kind of stunned at how quickly everything moved, because a lot of those people had never seen the aurora in their entire lives and thought it was a slow moving phenomena on the edge of the horizon, and suddenly it was right above them and writhing kind of like an animal almost. And it's just stunning to see. Here's another photo from that Aurora camera. You can leave it out all night capturing time lapses. And here you can see that higher altitude red from the oxygen. And also you can see the galaxy and also clouds moving from a 30-second exposure. So it's got a lot of interest in it, I think. And of course, it can take time lapses. So here's one where I set it up in the middle of a frozen lake and then went back and warmed up in the car for an hour. And this is what it captured. So again, you can see the moon, you can see the northern, or you can see the Big Dipper. And here is a substorm right here where things were relatively quiet. And then suddenly we have this breakup phase and the corona right overhead, just like you're right in the middle of it. So you can see it's relatively quiet. And you might be waiting in your car saying, oh, there's no aurora. I think I'll just have a chocolate bar and some coffee. But then suddenly you'll have to rush out of your car to start capturing imagery because things have gone bonkers in the last few seconds. Well, fortunately, you didn't miss too much of it because the automated camera was capturing that. So finally, with photography, you're always ending up in front of a computer and processing your thousands of images. Even if you get lucky, you might be punished by spending a lot of time in front of the computer with a sore neck. One thing that works really well with Aurora is panoramic imagery. And Alan Dyer of AmazingSky.net is legendary for his panoramas. And I tried to emulate some of that in one particular trip up to a lake in Yellowknife. This is the entire night sky, 360 degrees. And what you can see here is the auroral curtains, they move from east to west. So they arc over twice because you're seeing all the way south and all the way north. And in between, this auroral curtain comes right overhead. But what's interesting, you can see the breakup phase like we saw earlier, where it's just rags of auroral curtain, but you can also see some of those distinct curtains too. This is a panoramic, I guess it's like turning all the way around. You can actually see the back of my truck and the front of my truck on either side of the image. So I decided to just for fun wrap that around in Photoshop into this small world image. So you can see the bottom of the image there is now on the inside of this donut, and the zenith of the sky is this entire outside here. And that really gives us this idea of the south-facing sky and the north-facing sky. And it almost looks like magnetic field lines coming out of the earth in a way. So getting a bit artistic doesn't hurt at all if you're trying to show the idea that the aurora were all around you at the time you captured the image. Likewise, I wanted to take a panoramic in, I believe this was just south in the Yukon, just south of Whitehorse. And it was a beautifully clear night. You could see the galaxy very clearly. So I took a vertical panoramic of the entire galaxy as it stretched overhead, always keeping the galaxy in the middle of the frame, but moving from north where you could see the very dim aurora all the way to the south. And there were trees on either side of me. And so I joined those together into kind of a circular overhead panoramic. So this is directly overhead. This is facing all the way north of me and all the way south. And the trees kind of join up at their trunks at the bottom. And I think this photo actually got published in a data visualization journal because it was just maybe a different way of looking at the sky, because how do you envision the entire night sky? Well, there's more than one way to do it. And this is one approach to capture all the key elements that I found interesting in that night. Those kiograms we saw earlier, which are kind of like the spines of books, where you see the entire night sky as a single row of pixels. I've also wrapped those into circles just for an artistic idea. And they look exactly like irises of the eye. And so I'm thinking of turning this into a visualization where you can actually see the clock from sunset through sunrise of the entire night's activity, and pairing that with some of the time-lapse imagery. So again, being creative kind of pays off, I think. At least personally, I find it fun to play with Photoshop, play with Python and image analysis to come up with these. And again, that's how you make a keyogram, by taking the center slice of an all-sky image throughout the entire night and then stacking it like the spines of a book on a bookshelf. And if you take all those keyograms and stack them by night, you can very quickly see which nights on the left here, which nights had activity and what times a day have activity. And this is how researchers look at the results of their cameras that they have situated up north in stacks of keyograms. It's just like looking at the bookshelf. And I actually had the opportunity to work with the Aurora Imaging Group at the University of Calgary to do one of these interfaces. They were interested in this concept that I wanted to explore, where you take their all-sky imagery, which looks like this, and project it onto a virtual dome. You know, when you go to the planetarium, they have the dome where they project from the middle of it to simulate the whole night sky. And then you feel like you're under the night sky. Well, you can do the same thing with these circular images from my Aurora camera or from a research camera situated up north. But you do it virtually on a website. So if you go to Aurora X Keogramist, you'll see the results of our collaboration. I took their all-sky imagery from their research and public outreach cameras and reprojected it onto a virtual planetarium dome, and then allow you to look around with your mouse or your phone as if you're standing under it. And you can select any night from the last 5 or 10 years to look at. By understanding how keyograms work, you can pick out one that's an active night and look around as if you were there. And there's even a little tent in a forest, so you can really feel like you're present. And this data is sort of reprojected above you in a first-person view. So if you can't get out to Yellowknife tonight, but want to experience the Aurora, go to this website and you can immediately start exploring it as if you were there. So resources. Well, Space Weather Live, we mentioned a few times. It's really the best dashboard that I've found for knowing what is going on in space weather. And they also have a great learning system in their links and about. So it's worth reading up there. And they talk about solar weather as well as the impact on the Earth. Because Christmas is coming up, there's some really great books that I've read and recommend. Some of them are out of print, though 2 on the right are out of print, but you can always find them at Abe Books or even Amazon used. The Aurora Watcher's Handbook I find particularly interesting read from a technical point of view. And then the 2 on the left are both historical and modern exploration. And the one by Melanie Windridge, who's a space physicist, is especially interesting because she travels around and interviews a lot of the researchers and Aurora chasers. Finally, there's AmazingSky.net by Alan Dyer. He does a lot of trip logs and equipment reviews that are directly relevant to Aurora travel. He was even a speaker on a cruise ship that goes up and down the Norwegian coast doing night sky and Aurora photography. So I think he's a go-to resource if you really want to dive into the techniques, the travel logs, and the equipment. And in terms of Facebook groups, there's the Alberta Aurora Chasers with 170,000 members. That's always great to go to for a community feel. It's not just Albertans, it's sort of a global phenomenon now. And then more locally, thinking about those more southern latitudes like we're in, there's the Great Lakes Aurora Chasers, and they have some wonderful photography as well. And you'll see the difference in the characters of that photography because being further south, they get more colors, they focus on composition a little bit more too because they're shooting towards the horizon. And it's a really nice community as well. Finally, if you can't get up north, you can always check out the webcams. This link here, ctheaurora.com, has, I think, a pretty comprehensive list of all the live and time-lapse webcams that are available to see at any given time. So feel free to check those out. There's Aurora Max from Canada. There's also a few in Alaska, like the Geophysical Institute in Fairbanks. And there's also some live 24 frame per second cameras mixed in there as well. And there's also one in, I think, Minnesota too, that's a similar latitude to Michigan. So what they see there maybe is what you could see from your backyard. Finally, you can always participate. I've touched on the idea that Aurora isn't just taking pictures and traveling. There is a lot of unknowns, and the researchers do touch upon the citizen community of photographers and their sources of images. That's been happening since 1957, the International Geophysical Year, where volunteers filled out paper cards of the aurora that they saw and mailed them in to collection centers throughout North America to come up with aurora maps before there were satellites. And that continues with websites like aurorasaurus.org. So if you're taking pictures of the aurora, chances are you have a good opportunity that one of your photos might have something new in it and might contribute to the science behind understanding them. So I'd say overall, be adventurous and especially be safe with your aurora travels. They will take you to places that can be quite different, and they'll take you out there in midnight, in the dark, in the cold potentially. But you're never alone. There's a huge aurora community, and it goes all the way from art to science. And chances are, if you're at a very remote, beautiful place, there'll be another aurora photographer right next to you, and there might be no other people for miles. It's kind of interesting that way. I've run into people in Iceland in the same parking lot that I'd last met in Yellowknife years before, thousands of miles away, just by coincidence. So like any night sky viewing community, I think the whole sky kind of brings us all together. And being safe, but also being adventurous is a huge part of that. So that's my presentation. If we have time for questions, we'll try to answer those best we could. Otherwise, I put most of my content up at capturenorth.com in terms of learning resources. And I believe this presentation, the links will be shared as well for future reference. But always feel free to get in touch with me if you have any questions or want to share some ideas. I'd look forward to hearing from you. So I'll open it up to questions and stop sharing my screen. Thank you.
Thank you very much, Jeremy. That was a fantastic presentation. If you'd like to ask a question and you're on Zoom, you'll have to unmute yourself, or you could put it into the chat, and probably I'll be able to read that for you. And if you're at the Nature Center, you'll need to grab the microphone. So let's open it for questions.
Nicole has a question.
Does the aurora make any sound?
Oh, that's such a neat question. Yeah, that's like the big raging debate, isn't it? Because scientifically, you could say no. Like that, the scientists say, no, there's no way it makes sound. It's happening 60 miles above you. You know, the sound can't reach you down there. The air is too rarefied up there to transmit sound waves. And yet I've personally heard sounds correlating with aurora brightness when I'm viewing it, because you tend to be in very quiet places. And there are theories that it induces currents because it is a magnetic phenomena, and it does short out power lines. Therefore, it does interact with Earth through anything that conducts electricity, and that can be the ground below you. That can be power lines, which I've heard buzz when the aurora were above. And some people hypothesize that it's actually induces currents in the pine needles of the forests you might see around you, and you're hearing a buzz of these pine needles, basically. I don't have any answers to that, but I've heard all kinds of very interesting theories about, you don't hear them, but they can induce currents that you then can hear subsequently, almost like they're vibrating pieces of metal nearby you or conductive objects. So yeah, it's worth following that debate and seeing what it is. There are magnetic frequencies which have been converted to audio. They're detected by satellites. It's not really hearing the aurora, I guess, but it's the conversion of electromagnetic energy into audio waves. And you can look those up online to hear what the aurora would sound like if you could hear with electromagnetic ears. And it's quite eerie and interesting and surprising. I hope that answers the question.
This is Bob from the Nature Center. You had alluded to 60 miles. You may have mentioned it during your presentation. I was curious about the ceiling. At what altitudes do visual auroras occur, and at the maximum? And then how close to the Earth do they actually get?
Oh, neat. Yeah, I'd say there's sort of a hard stop at around 60 miles, if I recall. And that's when you get the pink fringe at the bottom of the aurora. The electrons really don't penetrate below that. And so you get a very distinct lower band of aurora. And that's why it looks like a curtain, because the emissions just have a hard stop around 80 miles. As far as how high up they go, they kind of drift off into invisibility, but they actually go high enough that the space station orbits through the top of the aurora, as I understand it. So that's probably 200 miles or so, 250 miles, 300. I'm just translating from kilometers in my head, I guess, but the extent of them can be very high. There's no distinct cutoff on the upper side, but there is kind of on the lower side. And then the colors, the species of the colors tend to be more dominant at different altitudes. And that's why you get that sort of rainbow of distinct colors at different altitudes. It very much is an atmospheric phenomena. And if you're in an airplane flying at maximum altitude, like a jetliner, you're really no closer to the aurora than you would be standing on the ground, because they do start at 60 miles. But if you're in the space station, you will be going through the tops of them on some nights, through the red tops of them, and they'll be sort of directly below you. So it must be a very interesting 3D experience from up there.
Good, thank you. One other question. I do appreciate your tales of your various adventures and that. As you were presenting that, I was thinking, has he ever been involved with bears? And I didn't expect to. As astronomers, we've heard noises around us at night and always wondered what was that. But then you mentioned beavers, and I said, well, that seems a lot safer than the bears.
The beavers seem safer. I find I've been attacked by mosquitoes.
Oh, well.
I found that quite discomforting. However, one of the other aurora chasers, who's now at the University of Alaska Fairbanks, that's Vincent Ledvina, he went to a relatively famous aurora chasing spot in Canada, Churchill, Manitoba, that used to be a sounding rocket range for exploring the upper atmosphere. Exploring up there, you do see polar bears potentially, and that is something to watch out for. So there's, I guess, briefings you have to take. Have I seen, when you travel up to those national parks where it's dark, yeah, you'll see bison and the occasional black bear, I guess. I think saw one grizzly, but polar bears was the interesting one that Vincent mentioned just a few weeks ago from his travels up to Churchill, Manitoba. So, but yeah, you're out in the dark, potentially alone, and a lot of animals like to come out at that time. So I guess that's part of the safety and being ready for it. And who knows what we'll see on the next trip.
You don't want to stray too far from the car then.
Well, yeah, it can be tempting to stray quite a ways from the car. That's true. But it's like anything, it's like risk management, I guess. And going with a buddy or something certainly makes it more enjoyable, but also safer too. Especially when you're trying to find a lens cap in the snow at 4 a.m.
I have a question for you, Wayne from the Nature Center. Is there a seasonality to the aurora, i.e. it's better in the winter and spring or fall?
That's a really interesting question. I'd say overall, there's not a seasonality to when you'll see them. They can happen anytime. But of course, there's the impact of the weather cycles and just simply the length of daylight. So for example, you wouldn't go out aurora chasing in Fairbanks or Yellowknife during the middle of the summer because you would just not get any night at all. Generally, people like to go on their yearly trips around September and October, and then maybe again around April. And I think the reasons for that is not that there's more aurora, but because you have a good balance of night and day, because the weather tends to be still fairly mild and fairly clear in the late fall, so you're not getting as much precipitation and cloud cover. You're not going to freeze to death like you would in January in Yellowknife or any of those places. There's just a lower risk and a higher comfort level with working in the fall. And also just the idea of you're generally photographing near lakes where it's dark, and a lake that isn't frozen will get you beautiful reflections of the aurora. So I think the most common time that I see people going out for their annual trips in Alaska or northern Canada tends to be around September and October for those reasons. But the aurora themselves don't seem to care. And if there is a seasonal variation, I'm not aware of it at this time, but again, this is probably one of those areas of research where there's some probabilistic change throughout the seasons. In the end, it's very earthbound factors, I think, that create an aurora chasing season.
Thank you very much. And also thank you very much for your presentation.
Uriah, Jeremy, we have a question in the chat from Uriah who asks, what was the event that brought you into this hobby?
I don't think there's any one event that gets you into a hobby, but I grew up in Edmonton, Alberta, and as some of you might who sort of in the 1990s, the aurora and the solar cycle, it was much more active, I think, a more active solar maximum than it has been in the last recent solar cycles. And you'd see the aurora a lot more frequently. In Edmonton, we'd see them camping all the time, and I just sort of grew up with them. When I moved out east for work and much further south, I realized that wasn't something most people see all the time. And it made me appreciate it more. So when digital cameras really started to get good for night photography, it made it worthwhile to try and capture some of that stuff that I remembered from growing up. And then the places that it takes you is just very interesting, and the people that you meet. And so getting involved with the science community and the aurora chasing community, as you know, community sort of drives your hobbies a bit because it's about the people, not just about the JPEGs and the raw files, of course. And then it sort of builds on itself. You meet some great people, you see things that other people might not have seen, and you see things at a time people might not have seen them, like those trips to Iceland, for example. You're seeing a waterfall in the middle of the night when it's just lit up by the aurora. Most people are already in bed by that time. And so you have this sort of different view of the world, I guess. And again, it's a very personal sky too. If you capture that picture, it's different than what anybody else is going to capture. And that's really sort of appealed. Like you think, what's the next interesting thing I could capture? It never really gets old.
Thanks, Jeremy. There's another question in the chat from Perry and Ashley. They ask, you mentioned citizen science in your presentation. Do you do any work analyzing the aurora on other planets like Jupiter or Mars? I understand Jupiter has a very strong aurora based on what I've read.
Oh, that's a really neat question. There is, so two thoughts on that, I guess, is yes, there are in any planet with an atmosphere and its own magnetic field in the solar system, there's going to be aurora. So that includes Saturn, that includes Jupiter. And one of the citizen science efforts that's happening with Jupiter right now, and please somebody correct me on the name of the mission, I believe it's the Juno mission. And it is orbiting Jupiter sort of from pole to pole to capture some unique data about the inside of Jupiter, but it's also capturing a bunch of images of Jupiter itself. And there's a citizen science effort by NASA saying, download any of the raw images and process them so that they are unique and interesting, and re-upload them to a shared site so other people can see them. And so you're doing the image processing directly from the data from a NASA probe. I find that just fascinating. Now that data is in the visible spectrum, but I believe most of the aurora for Jupiter are in the ultraviolet band. And so you might not see them in that particular mission, but some people who work with images have overlaid the ultraviolet views. I think some of them are from earthbound or orbiting telescopes, and overlaid them on top of the Juno cloud images of Jupiter, just to show this is what it would look like if you could look at it with full wide spectrum eyes in person if you were orbiting Jupiter. And that visualization of scientific data is a really key part in doing outreach and citizen science. You don't want to be just looking at tables of numbers. You sometimes want to have that really impactful image. And that's where citizen science can contribute. And yeah, I worked on some of those Jupiter images too, just personally, and I find it very rewarding to do, especially the poles of Jupiter are like nothing I expected. So yeah, there's always surprises.
Hi, Jeremy. This is Doug Bauer. I just had a question. You see ads for tours for Aurora tours and things, and I know people have gone to Iceland. I actually been to Iceland, not on that particular thing, but and they don't really ever see anything. A lot of people do, but some don't. Are there tours that go like in northern Canada or Alaska that actually are more scientific based in terms of knowing when they're going to see auroras that someone could sign up for?
Yeah, that's a really interesting perspective, that there are tour operators that are just about, yes, you might see the aurora, but also here's some wonderful food and a dog sled tour. And
right,
because they know they can't base their whole business model on maybe seeing the aurora when it might be cloudy, so they make sure that there's a whole variety of things to do.
Yeah.
I didn't want to touch too much on specific tour operators because I've never used them personally. I've just heard anecdotal things. But in the end, yeah, they can't control the weather and they can't control the solar weather. But there are more reputable ones that are more scientific. For example, speaking again of Churchill, Manitoba, they do have the Northern Research, I'm going to get the name wrong without Googling it, but the research center in Churchill has an annual trip that a limited number of people can sign up for, and they bring in photographers and scientists, and you can photograph the aurora for yourself, and they kind of curate the entire experience in more of a scientifically oriented perspective. So I'd put that in the same category as people that go on those sort of Arctic research cruises, I guess, and that you're exploring a bit more in depth than just seeing things. But yeah, it requires the research, and it requires, I'd actually try out AmazingSky.net from Alan Dyer, and you can see some of the trips that he's taken where he's been invited as one of the feature presenters or feature photographers. And that might be a good entry point into learning about some of those scientifically oriented trips, because yeah, that's a great confluence of science and photography, definitely.
Yeah. Well, thank you. Appreciate it.
Any other questions? Going once.
Not from the classroom. We were quite impressed with the presentation, and thank you very much.
Yeah, thank you for the opportunity. I really appreciated speaking to you all today. And again, I'm really glad that all of these clubs and communities across the US and Canada have been able to collaborate in these kind of presentations. So I look forward to seeing your next speaker, and I think I'll be listening in on the next one as well.
Great. Thank you very much, Jeremy.
It was a great presentation.
Very
really
good.
Enjoyed
Excellent.
It.
I actually have a question. You had mentioned cloud and stuff like that. So have you looked into things like sprites or elves, I guess, like on a thunderstorm cloud kind of
Yeah, those are really interesting, because the basis of them is similar to the aurora. You have high energy electrons energizing species in the atmosphere that are then emitting light that you see. And maybe it's no coincidence that the top of the aurora are the same red as the sprites that you sometimes see photographed, because they're energizing the same species to emit the same wavelengths. But I understand that it's even harder to capture than the aurora because of the, it's like capturing lightning and aurora at the same time. So I personally haven't looked into it, but I know some very good night sky photographers have it on their bucket list to capture that phenomena. And I've only seen a few pictures of it, but it looks completely captivating. And I'd love to learn more about it at some point.
Any other questions? Last chance. All right, great. Thanks again, Jeremy. That was an excellent presentation. This will end the meeting formally for the evening. Let me stop recording here.